everything you can see is bouncing light back at you. Some surfaces bounce light back so well that you can see a reflection. Smooth surfaces like glass, polished metal, and a pool of still water are all good reflectors. Perhaps the best reflector of all is a mirror. Using a mirror, a dancer and a television camera, we can investigate how light is reflected. Positioned here, the camera can't see the dancer's reflection, but look what happens as the camera moves. The dancer eventually appears. Her reflection is only visible from certain camera positions. Now you see her, now you don't. But why? To work it out, we need to know a bit more about the science of reflection. First, you need a narrow beam of light. Place a mirror in its path and the light changes direction. It's reflected. Change the single beam to 3 parallel beams and see what happens. Light bounces off a mirror in a very regular way. The ray of light approaching the mirror is called the incident ray. The one leaving the mirror is the reflected ray. Imagine drawing a line at right angles to the mirror where the beam strikes it. The angle between this line and the incident ray is the angle of incidence. The angle between this line and the reflected ray is the angle of reflection. So, what happens when the beam is moved? For each ray of light, the angles of incidence and reflection are always the same size. Light doesn't bounce off the mirror at just any old angle, which is why the dancer's reflection isn't always visible. Rays of light bounce off the dancer in all directions, but only some hit the mirror. Any light hitting the mirror reflects at a certain angle. Stand in this area and the light bouncing off the mirror enters the camera. Stand outside this area and none of the light from the dancer is reflecting towards it. To make the dancer visible, the camera has to move.